This is ChainMind, the decentralized AI network built for everyone. Just search ChainMind on Google, sign up, download the app, and you're in. That's it. You've joined the network. Run it on any device, phone, laptop, or server. Why ChainMind? Fully decentralized, fully yours.
When Uber announced a partnership with Zipline that could push 1 million drone deliveries a day, most people imagined pizza arriving faster than a traffic jam. What they didn't see, however, was the hidden battle for split-second intelligence that will decide whether those drones soar safely above our cities or crash into the very streets they're meant to bypass. The real story is not just about faster food, it's about how a decentralized AI inference network can give a swarm of flying couriers the brainpower they need, right at the edge. The first challenge Uber and Zipline must conquer is the sheer complexity of moving from a handful of test flights to 1 million daily sorties. That jump isn't a simple matter of adding more drones, it's a three-way knot of dynamic routing, payload optimization, and ever-shifting regulations. Imagine a drone leaving a restaurant in downtown Manhattan with a bag of sushi. Within seconds it has to read weather data that tells it a gust is forming over the Hudson, negotiate a no-fly zone that just opened near a school, and adjust its cargo bay because the sushi container is heavier than a typical coffee order. In a traditional cloud-centric AI model, each of those decisions would require a round trip to a distant data center, adding latency that could be the difference between a safe pass and a collision. Edge AI solves that by putting the neural networks directly on the drone, letting it see obstacles with its camera and lidar, predict wind changes, and verify compliance without ever leaving the sky. But edge devices are tiny compared to the massive servers that power today's AI services. They have limited compute, memory, and power budgets, so the models they run must be razor-thin, yet still robust enough to handle the chaos of an urban canyon. That's where a decentralized inference network like ChainMind becomes a game-changer. Instead of each drone carrying a static, monolithic model that can only be updated via a costly over-the-air firmware push, ChainMind lets every drone, ground station, or nearby edge server act as a peer in a shared mesh. When a new regulation is issued in a city, say, a temporary restriction on flights over a public event, the updated compliance model can be broadcast through the network, verified with a blockchain hash, and instantly cached on any drone that passes within range. The fleet becomes a living, learning organism, constantly syncing the latest intelligence while still being able to operate autonomously if it drops out of connectivity. Think of it as a neighborhood of friends passing notes. One drone spots a sudden gust and writes a short update about the wind pattern it just encountered. That note is then shared with neighboring drones, which can incorporate the fresh data into their own predictive models without ever sending raw sensor streams back to a central server. The result is a collective intelligence that scales with the number of participants, rather than being throttled by a single data center. As Uber's rollout moves from a proof of concept in a single district to a national network of hundreds of thousands of flights, the inference load spreads across an ever-growing web of nodes, preventing any single point from becoming a bottleneck. The rollout itself can be visualized in 4 distinct phases, each demanding a deeper level of AI sophistication. In the initial proof of concept stage, slated for late 2024, drones will operate in a tightly controlled zone with static navigation models that are pushed via simple over-the-air updates. The focus here is on safety and basic payload verification, making sure a hot pizza stays hot and a cold salad stays cold. By 2025, as Uber expands into multiple cities, the system will need dynamic routing that reacts to live traffic and weather feeds. This is where federated learning enters the picture. Each drone trains a tiny slice of a larger model on its own flight data, then shares the weight. Updates with the mesh. The collective model improves for everyone, but no raw customer address or proprietary routing data ever leaves the device, preserving privacy while accelerating performance. When the network reaches a national scale in 2026, the sheer volume of daily flights will demand a decentralized inference fabric that can balance load, manage versioning, and keep models in sync across continents. Imagine a delivery in Los Angeles that needs to hand off a package to a drone in Phoenix for the final leg. The two drones can negotiate a handoff in real time, each pulling the exact version of the navigation model that matches the current regulatory environment, all without a single request to a cloud server. By the time Uber aims for the global million-day target after 2027, the entire fleet will be operating under a shared, continuously refined AI marketplace, where third-party developers can contribute specialized perception models, like a night vision detector for low-light urban corridors, and get compensated through tokenized rewards. Regulatory compliance is another arena where decentralized AI can shine. Airspace authorities are increasingly demanding real-time proof that autonomous flights are obeying safety standards. With a blockchain-backed audit trail, every decision a drone makes, whether it's changing altitude to avoid a sudden storm or rerouting around a school zone, can be cryptographically signed and stored on the distributed ledger. Regulators can query these logs to verify that a particular drone followed the approved flight plan at exactly the right moment. Moreover, smart contracts can enforce region-specific rules automatically. For instance, a contract could be programmed to disable any flight path that crosses a stadium during a game, or to throttle deliveries over residential neighborhoods after dark. This programmable compliance reduces the paperwork burden on Uber and Zipline, while giving regulators a transparent, tamper-evident view of every operation. But here's the part most people get wrong. They assume that moving AI to the edge automatically solves every problem. The reality is that edge devices are still vulnerable to model drift, security threats, and the high cost of hardware upgrades. Weather patterns shift, construction projects reshape the skyline, and city ordinances evolve, all of which can render a once perfect model obsolete in weeks. A decentralized network mitigates this risk by enabling rapid, over-the-air model updates that are verified through consensus, but it also introduces new attack surfaces. A malicious actor could try to inject a compromised model into the mesh, hoping that a fleet of drones would adopt a flawed navigation algorithm. That's why cryptographic safeguards, immutable hash verification, and a reputation system for node operators are essential components of any robust, decentralized inference platform. Economic and environmental considerations also play a pivotal role. Replacing a portion of ground couriers with electric drones can lower per-order delivery costs, especially in congested urban cores where gasoline-powered vehicles waste time idling in traffic. However, the capital expense of building a fleet, installing charging stations, and equipping each drone with AI hardware is non-trivial. Decentralized inference helps offset those costs by reducing reliance on expensive cloud compute and by extending the usable life of edge hardware. Through efficient model updates that keep performance high without requiring frequent hardware swaps. On the environmental front, electric drones produce zero tailpipe emissions, and when they charge from renewable sources, the carbon footprint drops dramatically. Early simulations suggest that shifting just 30% of Uber Eats orders to drones could cut delivery-related emissions by up to 15%. Provided the drones are densely utilized and routes are optimized. For ChainMind, the Uber-Zipline partnership is not just a customer win, it's a living laboratory to prove that a decentralized AI inference network can power an entire industry. The platform can offer a curated marketplace of navigation, perception, and compliance models, allowing developers to license or contribute their own algorithms. It can host a federated learning hub where drones improve collectively without exposing raw data, and it can layer an incentive system that rewards local businesses or edge providers for lending compute during peak demand. All of this is tied together with blockchain-backed audit tools that verify model provenance and ensure that only vetted AI components ever run in the sky. By integrating directly with Uber's logistics API and Zipline's flight control stack, ChainMind could become the de facto AI layer for aerial last-mile delivery, opening new revenue streams while reinforcing the value proposition of a truly distributed inference network. The challenges ahead are real. A single crash in a populated area could trigger a regulatory crackdown and erode consumer trust. Model drift could cause drones to misinterpret a new construction crane as a harmless obstacle, leading to accidents. Network security must be airtight to prevent malicious model injection. Public perception, noise, privacy concerns, visual clutter could also turn neighborhoods against the technology. Addressing these risks will require rigorous testing, transparent communication, and resilient system design, all areas where ChainMind's auditability and community governance can add measurable value. Looking beyond food delivery, the same drone AI stack can be repurposed for pharmaceuticals, spare parts, or disaster relief supplies. The underlying decentralized inference fabric means each new use case can plug into an existing ecosystem of models and data, avoiding the need to rebuild from scratch. In the longer term, we might see a city where drones, autonomous ground vehicles, and even smart streetlights share a common inference fabric, dynamically allocating compute wherever it's needed most. Uber and Zipline's million delivery ambition is just the first milestone on that path, and the success of the venture will hinge on how well the ecosystem can distribute intelligence at scale. If you're fascinated by how autonomous aerial logistics, real-time AI, and decentralized networks intersect to reshape urban mobility, you've just heard the opening chapter of a story that's only beginning. The skies above our cities are about to get a lot busier, and the brains powering that traffic are being built today, one peer-to-peer connection at a time. Stay tuned, stay curious, and most importantly, stay connected with ChainMind. Follow us for the latest breakthroughs in decentralized AI inference, and be part of the network that will keep the future of delivery, whether pizza, medicine, or emergency supplies, flying safely and intelligently. The future is decentralized, and it's already taking off.